Hello everyone, I am Samyukta Nambiar. I am currently pursuing my third year engineering in electronics and telecommunication from JSPM's Padma Bhushan Vasantadada Patil Institute of Technology, Bavdan, Pune. Currently, I am an intern at EMERTXE and doing this internship based on embedded system. During this internship, I have built a car black box using a software MPLAB XIDE and simulated on the software PICSIM lab with the help of XC8 compiler. First of all, I would like to thank EMERTXE for giving me this opportunity. It was really a wonderful internship. Now moving towards the contents. What is a car black box? Requirements for building a car black box. Difference between microprocessor and microcontroller. PICSIM lab, CLCD, matrix keypad, interrupts, timers, and lastly, we will see project implementation. Now, topics learned during the internship. Introduction to C language, in that we have learned data types, conditional constructs, operators, arrays and pointers, functions, strings, storage classes. Introduction to microcontrollers and embedded systems. Introduction to PIC16F877A microcontroller. Introduction to MPLAB XIDE, XC8 compiler, and PICSIM lab. Requirements for building a car black box. MPLAB XIDE, XC8 compiler, PICSIM lab, PIC16F877A microcontroller, 16x2 CLCD, matrix keypad, timer 2, tactile switches. Now what is a car black box? A car black box is neither physically installed in a car or downloaded as a smartphone app. It links to a GPS device that measures and records vehicle speed, location, distance traveled, driving frequency, and time of a day the car is in motion. Now, what is a microcontroller? An integrated circuit or IC which is capable of being programmed to perform a specific task. The design normally have some restriction on it, like memory size, input-output capability, peripheral functions, etc. Now, difference between microprocessor and microcontroller. Microprocessor. All separate components are there. So it is more flexible, more design complexity is there. In case of microcontroller, all components are in single chip. So it is less flexible, less design complexity is there in microcontroller. Now embedded system definition. Any combination of hardware and software which is intended to do a specific task can be called as an embedded system. This is a PICSIM lab architecture. In that we have used PIC16F877A microcontroller. In that we have RS232 LEDs, buzzers, digital keypad, SSDs, matrix keypad, CLCD, ADC, LM35 temperature sensor, I2C, RTC, EEPROM, GIPO. Now this is a CLCD. CLCD is a character liquid crystal display. It is most commonly used to display ASCII characters. Communication mode is of two types, that is 8-bit mode and 4-bit mode. Now moving towards the MKP. Now MKP stands for matrix keypad. A matrix keypad consists of an arrangement of switches connected in matrix format in rows and columns. The rows and columns are connected in a microcontroller such that the rows of a switches are connected to one pin and the column of a switches are connected to another pin of the microcontroller. These keypads are most commonly used in digital lockers, calculators, etc. Now what is an interrupt? An interrupt is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests the MPU to stop the processing. The MPU acknowledges the request, attending the request goes back to the processing where it was interrupted. Interrupt source is of two types, that is internal and external. Now ISR. ISR stands for Interrupt Service Routine. An interrupt service routine is a software routine that hardware invokes in response to an interrupt. A basic example of an ISR is a routine that handles keyboard events such as pressing or releasing a key. Each time a key is pressed, the ISR processes the input. Now, what is a timer? A timer is a specialized type of clock which is used to measure time intervals. The timer is an important application in embedded systems. It maintains the timing of an operation in sync with a system clock or an external clock. It has many applications such as measuring time, generating delay, etc. Now, project implementation. Now you can see a dashboard screen. In the dashboard screen, we can see the current time, event, and speed. Now, this is a login screen. Here, we have to enter a password to redirect to the main menu. After entering the correct password, you will be redirected to the main menu. Here, we can see view log, clear log screen. Now, this is an event screen. Here, hash symbol indicates the event number. Then we can see the time, event, and speed. Now let's go to the project demonstration. This is a PICSIM lab. As you can see, this is a dashboard screen. Here we can see the current time, event, and speed. Now after pressing the RB4, we can see the enter password. After entering the correct password, we will redirect to the main menu screen. Here we can see view log, clear log. By pressing RB5, you can see an event. Here hash symbol indicate the event number, time, event, and speed. Here we can also do the reset. That's it. Thank you.